All right. For this one, there's a little bit of an edit if it didn't show up in yours, but just note that the time interval changed from 0 to 10 for part C there. Let's start seeing some of the information that we have. We have an elderly hospital patient contracts pneumonia. Doctor used advanced technological equipment to measure the amount of fluid in a patient's lung. The amount of fluid, so we have fluid measured in milliliters in the patient's lung, is given by the function, and now we have our equation, and T is measured in days. So we have all that information. We're going to delete all these. Clicking on the gear, click delete all, and we're going to start again. Okay, we have our function. Let's type it in. P of, again, we're going to use x. It makes it a little bit easier for doing the derivative. It's 24 plus 13 sine of x squared divided by 14. And we need to find p prime of 3. Okay, so p prime of 3 is 4.45929. So part A here. Oh, let's go back, change the pen. A, p prime of 3 is equal to 4.45929. Okay, we have that. And what's the meaning of that? This means the fluid in the lungs is increasing, keyword there, because it's a positive rate, at a rate of 4.45929, and now we got to put our units on here. Milliliters per day. Awesome. Part B. Find all times T for which the fluid in the lungs is increasing. Okay, so we got to do a increasing. Now I noticed that I couldn't even see any of the graph. Let's zoom out a little bit, see if we can find it. So particularly in the y direction, maybe from 0 to 20. Okay, that gets us closer, but we need to get a little bit higher. So let's say 0 to 40. Does that quite get us there? That does. I'm also going to put our time interval in here that we're going to be looking at later. And that should be actually a typo that's edited, that we're just looking at the first 10 days. So this is 0 is less than x is less than 10. We could put less than or equal to. So there we go. We're looking in that zone there. We want to find when it's increasing. It looks like it has a couple of zones of increasing. We kind of go uphill at the beginning, down in the middle, and then uphill again at the end. How do we figure out those uphills and downhills? We plot the derivative, which is going to be p prime of x. Now I'm going to go turn off the original by tapping on that red circle. And we're just going to look at the purple. What we want to see is when it is positive. Well, it appears to be positive from 0 to 4.68947. So from 0, actually let's write our sentence and then we'll start filling in some of this information. The fluid in the lungs is increasing keyword, 4. Now I'm going to leave some space for me to write there, but I'll go ahead and add my reason, because I know my reason. Because the derivative, p prime of x, is greater than 0. We say that something is increasing because the derivative is greater than 0. If it asked me for decreasing, I would have flipped that inequality, and I would have said p prime of x is less than 0. All right, so we have an interval here from 0 is less than t is less than 4.68947. But we should have a second one, and let's see if we can find that. And that's when it's positive from here to here. Now, we don't go all the way to 10.48598 because our time interval ends at 10. So we're going to say from 8.12, 1224, less than t less than 10. All right, part C. What is the maximum amount of fluid in the patient's lungs? Show the work that leads to your answer. All right, well, our work is going to be identifying candidates that it would happen for and then test those candidates. So first of all, this could be just done in a table where we're looking at t and p of t. We're going to look at the endpoints 0 and 10, but we're also going to be looking at these points where we hit a max. And remember, a max is going to happen when my slope changes from positive to negative. So when does that happen? It happens when this purple line changes from positive to negative. So we're going to go here at 4.68947, 4.68947, because the height changes from positive to negative at that point. This next point here is not going to be one of those because it's changing from negative to positive height. It's crossing the x-axis from below and going across to the top above. So that means that's a relative min. That would not fit for a max amount. But this last one here would have been 10.489598. So we got to test each of these candidates because 10 is before that last point. So we're going to check 0, 10, and 4.68947. I'm going to come over to my graph, add a table, and instead of x1, we'll call that t, and instead of y1, we'll call that p of t with our function notation. Then I just check each of these points, 0 and 10, and then that in between point, 4.68947. And you can kind of tell it looks like it's going to be the 4.68947. So we have a 24, 33.849169, and 37. So to answer the question, the max amount of fluid in the lungs is 37 milliliters. And that's it. I'll kind of let the video play here for a moment, so if you need to pause and look at the answers as a whole, you can go back and freeze the screen, maybe write some things down. And that's what we got. That's the end of the question. All right, thank you for watching, and good luck with your own questions.